Composite thread cutting cycle command G76. The G76 command is used for multi-pass automatic cycle thread cutting. It is often used for cutting cylindrical and tapered threads without relief grooves, enabling single-edge thread cutting with gradually reduced depth of cut, which protects the tool and improves thread accuracy. Once the turn parameters of G76 are set, the thread turning is completed automatically in layers. There are many parameters to remember, so it requires careful study. Let's first look at the first parameter, M, which is the number of finishing passes. It must be entered as a two-digit number, typically between 0,1 and 0,3. If M is equal to 0,3, there will be three finishing passes. The first pass is the finishing pass, and the second and third passes are repeat finishing passes, with a cutting depth of 0. These repeat passes help eliminate undercuts caused by tool deflection due to mechanical stress, improving thread accuracy and surface quality, and removing burrs on the thread flanks for better finish. The parameter R is the chamfer amount at the end of the thread, also known as the thread run-out amount. It is typically set between 0, and 20, and must be entered as a two-digit number. As shown in the diagram, AB to BC is a two-pass, where BC is the 45-degree chamfer line at the thread end, and R is the chamfer amount. The thread run-out feature allows for threading without the need for a relief groove. The parameter alpha is known as the tool nose angle, which is the thread profile angle, the angle between adjacent thread flanks. The values can be 80, 60, 55, 30, 29, or 0 degrees. The actual thread angle is determined by the tool. Standard triangular threads have an angle of 60 degrees. The parameter dmi is the minimum cutting depth, measured in micrometers, as a radial value, typically set between 50 to 100 micrometers. During turning, if the cutting depth is less than this value, the depth will be locked at this value. The parameter D represents the finishing allowance, which is the cutting depth for the finishing parts of the thread. It is a radial value, measured in micrometers, and is typically set between 50 to 100 micrometers. The parameters xz represent the absolute or incremental coordinates of the thread endpoint, which is point D in the diagram. The z value is obtained from the drawing, and for external threads, the x value is the minor diameter of the thread, is equal to nominal diameter minus 1.3 multiple pitch. While for internal threads, the x value is the nominal diameter major diameter, since the threading path is A to B to C, with the thread end transferring from point B to point C. The tool usually does not reach point D, which is a theoretical value. The parameter I is the thread taper value, which is the difference in radii between the two ends of the thread. I is equal to Rs minus Re, calculated as I is equal to Rs minus Re, measured in millimeters. For cylindrical threads, I is equal to 0. The parameter K represents the radial value of the thread head, measured in micrometers, typically set to 0.65 multiple p thread pitch. The parameter D is the depth of cut for the first pass, measured as a radial value. It is determined based on the rigidity of the machine and the thread pitch, with a recommended value of 300 to 800 micrometers. The parameter L represents the thread light, which is the axial distance between adjacent thread flanks on the same helix, calculated as pitch multiplied the number of thread starts, measured in millimeters. For single start threads, the length equals the pitch. As shown in the diagram, the term parameters of the G76 threading cycle command are summarized with their specific meanings and value ranges. Although there are many parameters, a program segment that would normally require multiple lines can be executed entirely with this single G76 command. Next, let's practice with an example. First, summarize the machining information. The diagram shows a cylindrical thread, the blank diameter before the blank diameter before. The actual minor diameter of the thread can be calculated based on the parameters. Then, sequentially determine the cutting parameters involved in the program. Finally, after sequentially feeding in the corresponding parameters, the thread cutting cycle command is completed. The G76 command is generally used for machining cylindrical and tapered threads without relief grooves, and it is particularly suitable for threads with larger lengths. The G76 tool can automatically complete all thread cutting cycles with multiple passes, and once the depth of cut and the number of passes are set, the process is executed automatically. This concludes the introduction to the G76 command.